Hello guys. So welcome to Ops Knowledge and it is the lecture 1 and in this lecture 1 we'll be talking about FMEA, that is failure mode and effect analysis. So let's go ahead and understand what is FMEA. As we know, FMEA stands for failure mode and effect analysis, and it is a systematic proactive method used to identify and address potential failures within a design manufacturing process, product, or system or software. Let's go to the next slide and understand about the history of FMEA, how FMEA started. So in 1940s, US military used to have a document by the name MIL P1629 which they used for the reliability of airplanes and tanks and all the equipments that they were using. So this was the initial document that we could say was initial time of FMEA. Later on, it was adopted by NASA. So NASA adopted it in 1960s for the aerospace safety. Then later on, it was moved to the automotive industry by Ford. As we know, Ford is used commonly for the mass manufacturing concept. So it went into the automotive industry in 1970s. So now let's talk about the types of FMEA. So there are total 8 types of FMEA, in which the first one is design FMEA or DFMEA, process FMEA or PFMEA, equipment FMEA or EFMEA, maintenance FMEA or MFMEA, the concept FMEA, the service FMEA, the system FMEA, and the last one is the environmental FMEA. So, while talking about how and when these FMEA are used, so design FMEA or DFMEA is used during product design to identify and mitigate potential product failures and design weaknesses. Process FMEA or PFMEA is applied during process development, manufacturing planning to prevent the process errors and ensure consistent production quality. Equipment FMEA or the EFMEA is employed in equipment design, selection, or operation to anticipate and prevent machine breakdowns and failures. Maintenance FMEA or MFMEA conducted during maintenance planning to optimize strategies and reduce the likelihood of equipment failure and downtime. Concept FMEA or the CFMEA is utilized in the early conceptual stage of development to assess and compare the inherent risks of different design ideas. Service FMEA is applied during service design and delivery planning to identify and mitigate risks impacting service quality and customer satisfaction. System FMEA is performed during early system architecture integration to address potential failures arising from interactions between subsystems and interfaces. Environmental FMEA used during product or process design and operation to prevent negative environmental impacts and ensure regulatory compliance. In these 8 types, only 2 types are quite frequently used in industry. Those are design FMEA or DFMEA, process FMEA or PFMEA. Let's go to the next slide and understand about the criteria for risk prioritization. So in this, we have 3 symbols which are to be understood and remembered. So the first one is S, that stands for severity of the failure mode. That how much impact could a failure mode do to your design or to your process. O stands for the occurrence of the failure mode. That how much frequently is the failure mode occurring in the whole process. D stands for detection probability of the failure mode. So, how easily you are able to detect the failure mode, or is it quite difficult for you to detect it properly? So, S, O, and D, all three ranges between 1 and 10. So, S, if it's least severe, so it will have a score of 1. And if it's highly severe or very dangerous to your process, it will has a value of 10. O stands for occurrence and how much frequently it is occurring. So if it is having a score of 1, then it's not too frequent. It's it's kind of a rare case that is happening. If the value is 10, then it's occurring very frequently. So the last one is detection probability, how easily you are able to detect it. If the value is 1, it's easily detectable. But if the value goes to 10, then it's very hard to detect. Let's go to the other parameter that can quantify the risk prioritization easily. So the next criteria is RPN, that stands for risk priority number, and it is the product of severity, occurrence, and detection probability. As told earlier, this should be the formula RPN equals to S into O into D. It is a relative measure of operational risk. Also, RPN can lay between a value from 1 to 1000. In the next PPT, in the next lecture, we'll be learning about how to calculate this RPN from the real life examples, and we'll also learn in the upcoming lectures that how we'll be able to make this FMEA document, because this FMEA document is a live process and a live document, so it has to be continuously updated. It is not a static document. So that's all for today. Thank you very much. We'll meet again.